You've seen it, right? The magic of AI. You type in a few words, and out comes this incredible art, or perfectly written code, or an answer to a question you've been wrestling with for weeks. It all feels so clean, so effortless. Like it's all just happening out there, somewhere in the cloud. But today, we're going to pull back the curtain on that illusion. Because behind every one of those seamless, magical moments, there's a very real, very physical price being paid. So, let's ask the one question that really gets to the heart of it all. What is the true price of a single AI query? I've got a feeling the answer is going to surprise you. Okay, so first up, we have to talk about AI's great illusion. The source material calls this a kind of great divergence, a turning point, just like the Industrial Revolution was. And just like back then, this revolution isn't happening in some abstract digital space. Nope, this is a physical, bricks and mortar, or, silicon and steel infrastructure revolution. And it's built on stuff we don't have an infinite supply of, like power grids and water. Which brings us right to the machine itself. To really get a handle on the scale of this thing, we have to look at its appetites. And let me tell you, it's not just a hungry machine gulping down massive amounts of energy, it's also an incredibly thirsty one. So let's start with that hunger for electricity. By 2030, and that's not far off, the global electricity consumption of data centers, the physical homes of AI, is projected to hit a truly staggering 945 terawatt hours. So what on earth does 945 terawatt hours actually look like? Well, to put that into perspective for you, that's about the same amount of electricity that the entire country of Japan uses in a year. Think about that. An entire massive industrialized nation's worth of power just for data centers. Now, let's bring it down from the global level to the individual level. We're not just talking about data centers in the abstract, because the type of work they do really matters. And generative AI, well, that's a whole different animal. Here it is, plain and simple. Every single time you ask a platform like ChatGPT a question, you're using about 10 times more electricity than a standard Google search. These complex models are just on a totally different level when it comes to energy demands. So that's the energy. That's the hungry part of the machine. But what about that hidden cost? The one we rarely ever talk about and the one that companies are often pretty shy about reporting? Let's talk about water. By 2027, the global water demand for AI is projected to reach up to 6.6 billion cubic meters. And this isn't some minor detail. It's absolutely essential. These incredibly powerful processors generate a ton of heat, and they need constant cooling, most of the time with fresh water. And again, to try and wrap our heads around that number, 6.6 billion cubic meters of water is about half of what the entire United Kingdom uses in a single year. Half a country's water supply, just for AI. And here's how that massive global number connects right back to your desk. The next time you're holding a normal bottle of water, think about this. Just 20 to 50 of those complex queries on an AI platform can use up that exact amount. You're essentially drinking your AI prompts. So when millions and millions of us are drinking our prompts every single day, that personal cost starts to scale up. And that creates these intense pressure points and very, very real crises on the ground for actual communities. Let's just take a look at Ireland. It's a pretty stark example. Right now, data centers there are already consuming 20%, 1/5, of the entire country's grid power. 1/5 of all electricity is going not to homes or schools or hospitals, but to data centers. That puts a crazy amount of strain on their national infrastructure. And hey, it's not just Ireland. This is a pattern we're seeing pop up all over the world. In Holland, it's 8%. Here in the US, that share is projected to more than double in just a few years, hitting up to 12% of the whole country's demand by 2028. This isn't some distant future problem. This is happening right now. And all that pressure, it creates direct conflict. In places like Uruguay, there's a Google data center being planned that will pull millions of liters of water every single day, directly competing with the drinking water sources for the people who live there. Suddenly, it's not some abstract environmental issue. It's a very real question of who gets the water. So beyond just consuming all this power and water, there are other critical issues, let's call them strategic bottlenecks, that could physically slow down AI's crazy growth, no matter how good the software gets. The biggest bottleneck might just be time itself. Look at this. We can build a massive, power-hungry data center in about 2 years. But the new high-voltage transmission lines we need to actually power the thing, Well, that can take up to 13 years. We're basically building the demand way, way faster than we can build the supply. And it doesn't stop there. You've got other choke points. The constant need for newer, better hardware is creating mountains of e-waste. The supply of some of these really critical minerals is controlled by just one nation. And a lot of the time, corporate secrecy means we can't even see the true scale of the problem. Each one of these is like a physical brake on AI's growth. Now I know, this all sounds pretty bleak, but here's where the story takes a really interesting twist. What if the very same technology that's causing this massive resource crisis is also our single best hope for solving it? This is what's known as the AI paradox. And this is the paradox right at the heart of it all. AI is, at the same time, one of the biggest new resource consumers in history, while also being our most powerful tool ever for optimization. The big question is, can its ability to make everything more efficient actually outweigh its own gigantic footprint? The race is on to find out, and honestly, the solutions are just as futuristic as the problem. On the power front, some people are betting on things like small, modular nuclear reactors to power data centers completely off the main grid. For hardware, engineers are developing these neuromorphic chips that are designed to work like the human brain, which is incredibly efficient. In software, we're seeing green AI models built from the ground up to do more with less energy. And in a wild full-circle twist, AI itself might be our best tool for managing the power grid, creating virtual power plants to perfectly balance supply and demand. The problem might actually contain its own solution. But this whole race to find solutions brings us to our final point. This isn't just a story about technology anymore. It's a story about power, both electrical power and geopolitical power. The AI revolution is completely reframing what global competition looks like. It's shifting the focus from who has the best code to who controls the physical stuff needed to run it. As the source material chillingly puts it, the conflicts of the future might not be fought over oil or territory. They may be fought over something as basic as the water needed to cool the processors that are gonna run our world. And so we'll leave you with this question. In the 21st century, who really holds the power? Is it the nation with the most brilliant software engineers? Or is it the one that simply has enough water and energy to keep the lights on? The answer to that is going to define the world we all live in.